Hello everyone. The Humble Math Tutor is here today to help you with rationalizing the denominator in expressions that look like this. The job is to rewrite this expression in a form where no radicals appear in the denominator. To achieve that, I'm going to multiply top and bottom by something which will dissolve this radical symbol. Multiply top and bottom by root 3. By multiplying by the red ink, you don't change the value of the expression because this is equivalent to the number 1. So that's perfectly legal to do. Now root 3 times root 3 in the denominator is just 3. It's now rational. No more root signs appear in the denominator. The top became irrational, but there's nothing we can do about that. The question is finished. That's great. In the next question, we're going to consider what happens if there's a cube root in the denominator. How would you go about rationalizing that expression? So our example is 2 over the cube root of 5. So to rewrite this with no radical symbols in the bottom, it's advisable to take one step first. Let's write 5 to the cube root of 5 in fraction exponent form. So let's write that as 5 to the 1/3. Now what we want to do is multiply top and bottom by something which will cause the 1/3 to turn into a 1, and then the denominator will be rational. So we're going to use that power rule. By adding exponents when you multiply powers of like base, I'm going to multiply top and bottom by 5 to the 2/3. Notice that 1/3 and 2/3 add to 1. So here we go, 5 to the 2/3 on top, 5 to the 2/3 on bottom. And when we multiply that out, the bottom is 5 to the 1/3 times 5 to the 2/3. You're going to add these exponents because you're multiplying powers of like base, and that's going to give you 5 to the 1. The top becomes 2 times 5 to the 2/3. And we're going to take a moment to rewrite this back in this radical format. So that would look like this. 2 times the cube root of 5 squared, all over 5. Remember, the bottom number goes in the little nook of the radical symbol and the top number goes here. And that can be simplified on one more line as 2 times the cube root of 25 times 5. And that question's finished because the denominator is rational. No more root signs appear there. In our next question, we'll consider what to do if we have a binomial in the denominator. So we're going to rationalize the denominator of this expression. 1 plus root 7 over 1 minus root 7. What we're going to do is multiply top and bottom by what we call the conjugate of the denominator. And that is the same binomial with the sign changed. So if this is minus, we use a plus over here. If this happens to be plus, we'd use a minus over here. We're going to multiply top and bottom by 1 plus root 7. This takes advantage of a certain feature of the difference of squares formula. Let's FOIL everything out and see how it goes. So that denominator, that's what we're most curious about. Remember, you're multiplying binomial times binomial here, right? So first term times first term is 1. Then your outer terms multiply to root 7. And your inner terms multiply to negative root 7. Remember, negative root 7 times positive 1 is negative root 7. And your last terms, let's consider those. A negative times a positive is a negative, and root 7 times root 7 is just 7. The middle terms add to 0, and no more radicals will appear in the denominator. The top, however, when we multiply it out, we're not going to shed radicals there. First term times first term is 1. Your outer terms multiply to root 7. Your inner terms multiply to root 7. And your last terms, they multiply to, remember, root 7 times root 7 is just 7. Continuing to simplify, let's see how this goes. We've got 1 plus 7 makes 8. Root 7 plus root 7 makes 2 copies of root 7. And the denominator is just negative 6. Notice that all the coefficients are even. So we can take a moment and divide top and bottom by 2 to simplify a little further. And that's going to give us 8 divided by 2 is 4. 2 root 7 divided by 2, that's just going to be root 7. And 2 divides into 6 3 times, and that negative sign can be migrated to it be in front of the entire expression. For the next example, we'll look at possibly the most difficult question type. That is a binomial in the denominator where one of the terms is a cube root. Let's have a look at that. Get my piece of paper ready. The expression where we have to rationalize the denominator is this: 3 over 2 plus the cube root of 4. We need to digress for a minute and recall the formula for factoring the sum of cubes. A cubed plus b cubed factors to this form: a plus b times a squared minus ab plus b squared. What we want to do is view these two numbers here in this binomial as these two numbers. That's what we want to do. We want to view this as these guys. Then we're going to multiply top and bottom by an expression in this form, so that the product will become a sum of cubes, thereby dissolving the cube root of 4 here. So we're going to multiply top and bottom here by something in this form using these numbers for a and b. So here we go. Remember, a is like 2, b is the cube root of 4. So we're going to create this expression here. So if a is 2, a squared will be 2 squared minus ab. So this is a and this is b, so it's minus 2 times the cube root of 4 plus b squared. Now b is going to be the cube root of 4, so we're going to square that. The cube root of 4 squared. Now what we do to the bottom, we do to the top. So this red ink here must be recopied here. So this would be 2 squared minus 2 times the cube root of 4 plus the cube root of 4 squared. The next step is to begin multiplying things out. But we have a handy fact to help us out. A handy convenient thing. Notice that this times this gives you an immediate sum of cubes. But that's what this is. This line here has exactly this form, so there's no need to spend all the time multiplying this out. That would take a lot of time. We can skip immediately here to this form, a cubed plus b cubed, where a is 2 and b is the cube root of 4. So this would be 2 cubed plus the cube root of 4 cubed. The top, however, simplifying out to this. The 2 squared is going to be 4. This guy doesn't change, minus 2 times the cube root of 4. And I'm going to write this guy in this form to help out. I'm going to write this as the cube root of 4 squared, because the order you execute these commands in doesn't matter. I can take the cube root of 4 first, then square it, or I could square the 4 and then take the cube root later. So I'm going to put it in that form to make simplifying it a little easier. And this is going to give us on the next line, 2 cubed is 8, and the cube root of 4 when cubed again gives you 4. Up top I've got 3 times 4 minus 2 times the cube root of 4 plus the cube root of 16. Okay, finally we're now ready to multiply the 3 through against these 3 terms inside the brackets. The next line would look like this. 12 minus 6 times the cube root of 4 plus 3 times the cube root of 16, all divided by 12. This form here has some common factors in the top and the bottom. I can divide top and bottom by 3 to simplify it a little further. So that would give us this. Dividing by 3 would give us 4 minus 2 times the cube root of 4 plus the cube root of 16 divided by 4. And the denominator has been rationalized. No radical symbols appear there at all. If you enjoyed this video, please like, subscribe, and share. In the comments section below, please make any suggestions you have for topics you'd like to see covered. Thank you very much.